To all the participants and prospective participants, on behalf of Nashik Engineering Cluster, it gives us immense pleasure to announce the Metrology Dexterity course in association with Mahindra and Mahindra. It has been a great initiative based on a concept which is possibly prevailing in Europe and United States, where industries recruit young engineers and then they tie up with some institutes to further do the skill development. We at Nashik Engineering Cluster have four different verticals: product development, value chain, calibration testing, business services, and skill development. It is essentially formed under Ministry of Industry and Commerce, Government of India. This unique scheme of industrial infrastructure upgradation scheme to provide technological and skill development support to medium, small and even large industries. So in this context, we are in fact taking a very path-breaking step of conducting this course in association, or in fact a joint activity with Mahindra. It was initiated by Mahindra and designed by Mahindra. The objective of this course is to provide metrology and metallurgical related skills for young engineers and also for young officers to understand the importance of metrology, the inspection, quality control, and under one roof. That is the big advantage of Nashik Engineering Cluster. Under one roof, they can have the practical training and exposure of understanding various instruments, various measurement methodologies, and the acceptance criteria pertaining to the metrology. And we would like to take this initiative further and support Mahindra and Mahindra for all such events. Thank you.
The program of Metrology Dexterity is developed to address need of industry. It is seen that the understanding of metrology practices is inadequate with our engineers. Well, metrology is a science of measurement, and dexterity means ability to handle the task effectively and efficiently. A need is felt to train our quality engineers on metrology aspects with dexterity, covering dimensional measurements and metallurgical checking, so that they can deploy it back at their workplace. This two-day program developed with Nashik Engineering Cluster is to cover this need. In this two-day program, the participants will get an opportunity to handle 28 types of different measuring equipments. They will understand the application of these equipments in the real life scenario. In dimensional measurements, they will be handling all conventional equipment and getting to know about many non-conventional equipments and their applications. In metallurgical area, they will be hardness checking, different hardness levels, physical properties of the material and their checking, different crack detection methods and handling of some of them. On surface treatment, they will be understanding on salt spray chamber, the salt spray life parameter of the product and the interpretation of the failure pattern. They will also understand calibration principles, concept of calibration and a demonstration of some of the equipment. A session on GD&T will give them insights on drawing interpretation and real life usage of GD&T practices. GD&T can very well link design intent to manufacturing process sequence, FTG, that is fixture, tooling and gauges, and inspection practices. Participants will be taught on this and the real life usage of these things. At the end, there will be exam covering practical aspects and theory aspects. The qualified candidates will get a certificate from Nashik Engineering Cluster. Well, NEC has very well equipped infrastructural facilities with very well equipped metallurgical lab, metrological lab and NABL accredited calibration lab. Hence, it is the best suitable venue for this kind of programs.
Hello friends, today is the first day of program Today we will learn on handling conventional measuring instruments correctly. The teaching will be using I do, we do, you do method. You will observe how to use the instruments correctly. Then you will actually handle it in our presence, followed by taking readings yourself. Followed by that you will see CMM checking, interpretation of CMM report, cylindricity checking, profile checking today.
Bore gauge. Bore gauge is used for measuring bore diameters. This is an instrument to be used along with dial indicator. List count of this instrument is depends on the dial indicator used. Mostly dial indicators of list count of 1 micron and 10 micron are used. Various ranges of bore gauges are 6 to 10 mm, 10 to 18 mm, 18 to 35 mm, 35 to 60 mm, etc. Now setting up bore gauge. First see the size which you desire to measure, or you can see the drawing for nominal size and select the range of bore gauge accordingly. Then see the tolerance of component as per drawing. Accordingly select the list count of dials. The list count of dials should be at least 1/10 of the tolerance of component. Now take the bore gauge, assemble proper anvil accordingly to the size. Then insert the dial indicator and clamp it. Engage the bore gauge with setting ring or component to be checked. Now loose the clamp and slightly insert the dial indicator inside so that the pressure of at least half round of dial indicator is generated. Set the dial indicator as per required size. Now bore gauge is set and ready to use. Take the component to be checked and check ID with the bore gauge. Wheel protector. This is an instrument for angle measurement. There are various types of wheel protectors available in market, having list count of 1 degree, half degree, 5 minutes. This protector have list count of 5 minutes. Now see how to check angle with this instrument. Take the component to be checked, rest the blade on it and give angle to rest another blade on another face. Read main scale, see which division of vernier scale is coincide and calculate angle. Angle of this component is 63 degree. Slip gauge. It is the primary reference standard having close tolerance for its nominal size and flatness. Various grades of slip gauges are K grade, 0 grade, first and second grade. Normally K and 0 grade slip gauges are used in laboratory for calibration purpose. Grade first and second are used in shop floor tool room. Again there are various combinations as per requirement like M122, M112, M88, M32, M47, etc. According to set combination, we can select required size and assemble the slip gauge accordingly. The method of ringing of slip gauge is like this. Layout inspection. Clean the surface plate, put height gauge, V-block, lever dial, etc. on it. Apply lever dial to height gauge. First, keep the component to be inspected on V-block. Put ball probe of lever dial in ID of component. Give pressure to lever dial around 20 to 30 divisions and rotate component around. It is the concentricity of ID with respect to OD. Second, put the probe of lever dial on top surface of V-block and run lever dial on this surface. The total indicator reading shown is the parallelity of top face with respect to bottom face. Third, keep the V-block vertical and run the lever dial on vertical face from bottom to top end. The total indicator reading shown is the squareness of vertical face with respect to bottom face. Surface roughness testing. This is a device for measuring surface roughness. We can measure various parameters of roughness like RA, RZ, Rmax, RT, etc. Results are provided with a graph, cutoff length, evaluation length, etc. Contour measuring machine. This is a machine which is used for measuring profiles of various machine components, gauges, molds, etc. With this machine we can measure radius, angle, distance, height, etc. with a close accuracy of plus minus 0.08 micron up to 100 mm range. Coordinate measuring machine. This machine is used for coordinate measurement along x, y and z axis. Range of this machine is x 700 mm, y 700 mm and z 600 mm. This is an open bridge type and having accuracy of 1.8 plus L by 300 micron, where L is in millimeter. We can inspect various types of machine components, jigs, fixtures, molds, sheet metal assemblies and checking gauges, etc. Video profile, that is vision inspection system. This is the advanced profile projector. We can measure various parameters like length, angle, radius, profiles, etc. One of the advantage of this instrument over conventional profile projector is even after inspection we can calculate the parameter with the help of soft data. We get results in the form of 2D drawing, Excel sheet. If required, the profile image of component is also available in soft copy, which is useful for R&D and for designing the component. Roundness testing machine. This machine is for testing roundness, straightness and cylindricity. Here is a rotary table with the help of which first the component is made true with respect to center. Then the various locations at which we desire to test the component will be defined. With these inputs, machine will sense the error with the help of probe and the value of required parameter will be displayed. Spectrometer. This is present day method of checking chemical composition of metals alloys. NEC has Spectromax instrument from Germany. It can measure 18 elements up to third decimal within minutes. The results are accurate, reliable and repetitive. The earlier conventional test tube method take 2 days. Calorimetric would also make 1 day. What can be checked? Iron based steel, cast iron, copper based gunmetal, bronze, brass, nickel brass, aluminum based mazak, zimac and others. It uses a principle of sparking on a flat test piece around 15 and 30 mm diameter. This spark gives out a spectrum which is read for an electronic interface depending on the amplitude, location of spectrum line. The elements are read at receptors. The receptors convert the spectrum line into percent reading. Argon is continuously flushed over to avoid any entry of air over the spark. A computer attached to the system gives printout. The data can be stored. Micro hardness test. It not used for mass production or serial production, mainly used for analysis. When one does not want to damage the job with a dents or indent mark, or where the area available is very small, or where the location is odd, where one wants to measure the hardness. The scale is 0 to 1000 HV or equivalent to 0 to 600 BHN and from 20 HRC to 70 HRC. A load is from 300 gram to 10 kg. The magnification of impression is 50 times. The impression is in the form of diamond. The average of the diameter is the reading converted to HV scale. The job is polished to mirror finish and mounted on a black-colored block. This block is held between jaws and implantation is done. Scale conversion from HV to HRC to HVN are available. It gives error less than plus or minus 10 HV or 1 HRC. Rockwell bench mounted hardness tester. This is typically used for mass production checking. At random, after every 10th or 15th job, one is picked up. Its flat surface is cleaned by butting. The top and bottom surface has to be flat horizontal. The job is put on the table. The table is raised by a wheel. Once the indenter touches to the job, the wheel is rotated slowly till the inner pointer touches to red line. At this level, the job is loaded by 150 kg. The load is removed and the round scale is read. When the pointer stops completely, the black dial is for HRC and the red dial is for HRV. For HRV, 100 kg load is given. For HRA, 60 kg load is given. The HRA scale is small than HRV, which is smaller than HRC. ROHS, resistance to hazardous substances, or XRF. In this case, X-ray is bombarded on a reflector and the reading is taken from a reflector ray. Depending on the 5 elements which are defined as hazardous by European standards, these elements are hexachrome, tribromine, mercury, lead, cadmium. The limits of acceptance are specified in these standards. The electromagnetic spectrum emanating from specimen to be checked are read by an electronic interface. This converts the line pertaining to element by amplitude, location or spectrum into ppm, parts per million.